My name is Allison McEntire. I'm a mobile developer at Urban Outfitters. And today I'm going to talk about testing asynchronous code in Swift 5.5. The team I work on at Urban is Newly. We have two apps. The first app is Newly Rent. This is a clothing rental app. It's a subscription box model. We allow users to purchase and add clothing to their box, and it's an alternative to fast fashion. Our second app that we've launched recently is Newly Thrift. Newly Thrift is a marketplace for users to buy and sell clothes, and we use Stream for our chat solution, so thank you, Stream. It's written in Combine, and we are refactoring it currently with async await. So today, I will be talking about refactoring unit tests, how to move from Combine to async await, testing structured concurrency, using task to phase out wait for expectation, and using async stream to mock network calls. As I give my talk, I'm going to be sharing with you code from a demo app, a learning project I've been working on, and this is the Meme Remaker app. And what the Meme Remaker app does is it fetches an array of possible memes, possible meme templates from a service. It lets users input their own text, and then it remixes the meme with the text with a random image, sometimes with hilarious results. And it's built with Swift UI and Combine, and then I refactored it to use async await. So now I'm going to talk about how I refactored it from Combine to async await. The basics of the app are that I have a network call here in Combine. It fetches meme names from a service. The service returns a string array. Very simple. We've already looked at some examples of this before, but the data task publisher sends the request. We receive either an error or data to decode, and then we return that through the publisher. On the view model, we update the view model like this. We have a completion that might return an error. Otherwise, the received value is parsed on the view model. There are 999 meme templates available to me. Some of them didn't fit my UI. Some of them don't work well with my top text, bottom text format. And some of them are just offensive. And so I eliminated those with my discarded meme array to measure against. So as we parse through the memes that we receive, we discard the ones we do not want to see. The rest are appended to the array that is published to the UI. Once the user inputs their text and then hits the submit button, we make this call, which again hits our service. We send a URL to fetch the final meme. The URL is a string that takes the input text from the user and then also generates a random meme image, like I mentioned, and returns the generated meme from the service. And that is returned as data that we update the UI with UI image. To test this in Combine, your test would typically look like this. You set up an expectation. You fulfill the expectation through the completion block, and then you can assert against the received values. Here I'm asserting that I have received condescending Wonka and confession kid, the final meme template available to me through the service. As I was preparing this presentation, I found this comment in our code base. We are very, very, very excited to refactor our app. We love Combine. We had a great time using it. But we are having a great time refactoring our code to use async await. And we're especially having a great time refactoring our unit tests to use async await. So again, if we look at this fetch method in Combine, if we refactored this for async await, we've seen this previously. Vince's talk gave a great overview of this. We very simply try await session data for our URL request. That returns a tuple. We get data back. Just like Vincent, I don't want to do anything with the response, so I'm going to discard that and then decode the data and return it. It's interesting that the response can throw an error. And so I don't have to do anything except for handle the error, which I'm obviously not doing here. So what makes this so simple to test is that all you have to do is assign the async keyword to make the test function asynchronous. We can then await the response returned by the function and assert against the values as expected. XCTest won't pass to the next line until meme names is returned. Anna mentioned dopamine. I get a lot of dopamine from red and green check marks. Here we get a red check mark, which proves our test works, because if we fix that typo, it passes meaningfully. We have a test that works. Our rage is assuaged. So just to review, Combine is Apple's take on functional reactive programming. We leverage publishers that emit values over time. We transform those values using operators. Async await is structured concurrency. It reads more like synchronous code. It eliminates the problem of too many nested completion handlers. It allows for throwing errors. There's context-aware code compilation, which is lovely. And tests can be more meaningful. So let's dive into testing structured concurrency. Any method that adopts async await can be tested by adding the async keyword to the test function. This function adopts async await by awaiting the network call to fetch an image and then creating a new image from a new object with the response. To test this function, we also apply the async keyword to the method and await the expected result before asserting that the result meets the expectation. This test can throw, so we should add the throws keyword to the method to indicate that the function can throw an error. I'm sorry, this function can throw. Similarly, we would add the throws keyword to our test. And then we can update our test with the throws keyword, which allows you to add an assertion against any error the test might throw. Challenges. There are some challenges with using async await in XCTest. One of them is that not all assertion APIs currently support concurrency. If we replace XCT fail with XCT assert throws error, we'll see a compiler error that async in an auto closure does not support concurrency. And there it is. So we do have to fall back on some workarounds. One of those is that we cannot use all of our assertion APIs that we're used to. Our second challenge is that await will not time out. Here, I'm attempting to test the call that updates the meme array in the view model. If you look at the compiler, you can see the test started. I could have made this video 30 minutes long. We could spend the rest of our lives awaiting our string array. This test will never complete. It will hang forever. So while we do have these challenges, not all XCTest assertion APIs currently support async await. The methods mark await without additional handling will hang forever. And we have the possibility of false positive tests because our assertion lines are never reached or they're reached before other lines of code complete. There's also benefits. Most tests are much more simple to write and read. It allows for assertion against thrown errors. And we have the same context-aware compilation in XCTest that we have in the rest of Xcode. So like you saw, you get some helpful error messages as you're experimenting with this in XCTest. Awaiting a return type. Anytime you have a return type to await, you can run a simple test. Because all this call returns is a string array, defining the result will complete the awaited call and continue to the assertion line as soon as the value is returned. So you can see with the breakpoint that I added that we hit that line, and then we get our failed test, we can update it. Using a synclet. Vincent mentioned earlier that you could use async let to make these calls run in parallel. So if I wanted to fetch each of my memes individually by the order that they occur in the string array, all I would have to do is declare async let, and then they would be awaited by my print statement. All of these might download before the awaited line is reached, and so that could speed up our app. So if we apply async let to our test and our view model call, we can create a situation that's much like awaiting the return type, even though the return type of this function is void. We don't actually have anything that this function is returning, but if we declare it with async let, the compiler will go to the next line. And so then we have a meaningful test. Task and task cancellation. To improve my parsing method, I decided I wanted to replace my service call that returns just a string array, a complete string array, with async throwing stream. So I wrote a new function. This returns async throwing stream. It still makes use of try await session data. And the tuple still returns either data or the response. The stream will continue to emit its values or errors as it's received through the continuation. And finish is only called on an error, so we might continue to receive values. Testing this function is going to be a little bit more tricky because of that. To test this function, we can declare a task variable and then cancel the task. But what's going on here? If we add a breakpoint, we're not actually hitting the line. This is a meaningless test. We can't fail this test. It's not possible to fail this test because we're never hitting the assertion line. We might think, well, maybe we can go back and use XCTest expectation instead to resolve these challenges. However, this test will also hang forever. Will never complete. So that's not much of an improvement. To create a meaningful test, we can use a combination of wait for expectation and task cancellation together. And then our expectation line is reached. And of course, to see it fail meaningfully, we should add an XCT assert. Let's make it fail to prove that it works. And it works. However, this is probably code smell. Probably the best thing that we should do is call finish on our stream continuation itself, in which case we can simplify this test, again, by just using an async let in the same way that we saw previously. But we'll look at some other strategies in a minute. To review, testing is wonderfully simple if you have a return type to await. Using async let allows for producing effects and testing them over time. It can also speed up your tests. And wrapping a function in tasks allows you to cancel the task when the code is ready for test assertions. And if all else fails, you could try task cancellation plus wait for expectations. That might work. But let's look at how we can use task to phase out wait for expectation. Before Combine, this is how we might have set up our original function. So this code passes the asynchronous results to an escaping completion handler. And that can also be tested with async await without making any changes to the code. And I find that really, really cool. So in this function, the image is returned through an escaping completion block. And normally we would test it this way by declaring an expectation and then waiting for the expectation and fulfilling it. But now, if we add the async keyword to the test, we can actually simplify this test with async await without updating the tested function at all by using with checked continuation. Now, if we run this test again and we pass an image name to it for a meme that we know doesn't exist, we're going to get an error from the service. What do you think is going to happen to our test? Well, it's not going to run like we expect. So if we search for condescending grumpy cat, and we pay attention to what happens in the debugger, we're going to see this error, Swift task continuation misuse. This test leaked its continuation. Did anyone spot why? It was a few slides ago, so I don't really expect you to remember it. But the reason is that this error appears if a continuation that you created with checked continuation or with checked throwing continuation doesn't report success or failure before being discarded. That's what's going to lead to your resource leaking. I had a bug in my code. Here, I was only returning completion if I actually had an image. If I didn't receive an image, there was no path. There was nowhere for the app to go, and so there was no way for the test to test it correctly. My resource leaked. So to rewrite this, all I have to do is make sure that I can pass on a nil image if a nil image is what I receive. And once I update my completion here, then I'm handling the function, I'm handling all paths through this function. And then my test will work. Now, although I think condescending grumpy cat would be a really useful meme template, it does not currently exist, and so my test fails. If I run it again, my test passes. We can also improve our combine-based tests with continuation without adding async await to the combine function. So here's my previous combine function where I fetch the meme image. I'm going to wrap my combine function in a value that receives an image through with checked continuation. The continuation will pass the value that's received through the combine function back up to that variable image, and then I can assert against it in my final assertion line. In this video, it did not run. But in this video, you'll see that this eliminates the need for wait for expectation completely. Okay. So we get the same result as we did with our escaping completion handler function. Both functions can be updated to use async await without actually changing the code that we're testing. So you saw this slide already. Previously I mentioned, or you haven't seen this slide yet. Task continuation can be used to test code that hasn't adopted async await yet, and task continuation can also replace wait for expectations with actual values to test against. Values we actually expect. So now I'm going to talk a bit about using async stream to mock network calls. We should definitely mock our network calls in our unit tests. We want to make sure that we are achieving faster CI/CD build times, and we are cognizant of our cost reduction. We can use async-let to test this view model, but it only gets us so far. What if we want to assert against calls made to the service during parsing? Or what if we want to dig deeper into the array at the point of creation? What if we want to create and post memes remotely as we parse our stream? We can intercept our network requests and test against those requests using a combination of URL protocol and async stream. First, we create a protocol that conforms to URL protocol, and that can be set as the session configuration for URL session from our XC test environment. Next, we add a static property, continuation, that will hold the continuation, and a static property requests, which returns the asynchronous stream that emits the requests. And inside that request getter, you create a new async stream and store its continuation. Then you add a final property to store each request as it is emitted. To intercept our URL request and send a mock success back in the return, we initialize an HTTP URL response, and that returns a successful status code. And then we pass this and the empty data object to the URL protocol client in the start loading method. To intercept each request and store it in our last request property, we need to intercept the data of the request input stream. So we need to extend input stream to make that data available. And now we can intercept the data of each request as it's made and pass it to our last request property. So to set our mock URL protocol session as the session configuration for our testing environment, all we have to do is initialize URL session configuration of a type default, and then we can add it to the test configuration protocol classes. So then your situation under test can access the test session if it has a way to have a test session on the situation that you're testing. And then you can set your configuration for your test session as your test configuration. So now we can intercept our URL session requests as they're being made. And then we can return a mock result type to our view model test. But as I mentioned earlier, the awaited function getMemeArray is never going to complete because await itself will never time out. To handle this correctly, we first must add async-let to produce effects and observe them at the same time. So let's see what happens. It's going to hang indefinitely. This test will also hang forever for the same reason as our previous example, and that's because the stream never completes, and so the test never completes. So to resolve this, you did see this slide before. I want to remind you that task continuation can be used to test code that hasn't yet adopted async await. And task continuation can also replace wait for expectations with actually expected values. So now we're going to add a timeout task that we can use to achieve some pretty nimble test results. through the continuation. First, you want to create a generic success type. Our timeout task will return success if it returns anything. If the task doesn't return any results at all, then the success is void. Additionally, you're going to define a timeout error, which will throw if the task times out. You should initialize a parameter to store the maximum duration for the test. And you should also initialize an operation parameter to pass to the timeout task. That needs to be escaping so we can store and execute the closure outside of the scope. And we need to mark it sendable to indicate that it's safe to transfer between concurrency domains. We should add a new property to store the result of the task through checked continuation. And inside the getter, you start by calling with checked throwing continuation to get a continuation. So this lets you either complete successfully or throw an error if the operation times out. Then we add the asynchronous task that sleeps for the given number of seconds. We can use the stored continuation to throw a timeout error. Next, we add an asynchronous task to execute the operation of the closure. If that completes successfully, then you can use the continuation to return a result. These two tasks are going to run in parallel. Whichever task completes first is the one that gets to use the continuation, while the slower task gets canceled. Once we wrap our function with the timeout class, we can then use it with other tests to observe a meaningful passing and failing test to the method we looked at previously that updates our meme array and our UI on our view model. We can use that throughout our code to time our tasks out. So now let's add that to our mock stream session. First, we need to declare a few async let tasks so we can observe their effects as they're produced. Next, we'll wrap our mock session in a timeout task that will return an array of our requests. And then we can await the result of our async lets. We have a fetcher, which can be discarded. It's a void. And that leaves our request response, which includes the values that we can use to test our assertions. And now we can more nimbly test these requests as they are made. So if we run this test, we'll see that it passes. We know we don't get grumpy cat, so if we change that to true, we'll see the test fails. If you're looking through the code, you might have a question about a line that I've added because I mentioned that I receive 999 results from my endpoint, and then I parse them out, and I expect to end up with 799 results. So there's a line of code in there that you might think, why did she add that line? Does anyone see it? Prefix, yes, thank you, Donnie. I set my prefix to 4 because I made this video on the LNER train, and the Wi-Fi is very, very, very slow, so I didn't want to tax the network too much. I just wanted to get the first 4 results and test against those. So in using async stream to mock network calls, mocking the network can be useful when you want to test the network. And to test time-sensitive asynchronous code, we can run concurrent tasks to trigger the code under test and observe its output or side effects. And await can hang forever, so you still may need to implement a timeout to test asynchronous code. And final thoughts, I think the future of testing async await is very bright. If you look on Swift Evolution, Swift forums, you'll see that there are proposals for updating async await and its use in XT test, and so we have lots of methods coming to us down the pipeline. And I also want to take a moment to acknowledge the people who have worked in this area and helped me develop my knowledge of unit tests and helped me explore unit tests, especially the Modern Concurrency book, the Ray Wenderlich book by Marian Todorov, and all John Sondel's wonderful blogs, and all of my colleagues at Newly. Thank you.
Awesome. There we go. It's like I'm crossing a barrier here of the mic switching on. Awesome. Really awesome talk. We have some questions. Okay. So the top question is, how does the test suite know how long to wait for the asynchronous method to return a value? If a value is never returned, will the test time out?
In the situation where the test hangs forever, how does the test know?
How does the test suite know how long to wait for the asynchronous method to return a value? And then in the case of no value, will it time out?
I do not believe it will. We looked at the example where we used task cancellation. We wrapped a synchronous stream with cancel after the end of the task, and we saw that it hung forever. It never completed.
Cool. Any questions in the audience, by the way? Anyone wanting to skip the queue? Okay. Do you have manual testers in the team, or do you have everything unit/UI tested?
We do. We have a great team of QA engineers that test our code manually. So we are not completely reliant on unit tests, but we are unit tests are a value at Newly. We have a kind of a pact with each other that whenever we submit a PR, we add unit tests to the PR. And we found it to be of great value in writing our code. I was talking to someone at lunch who mentioned that he has had a situation in the past where he knew if he had written a unit test, it would have helped him identify a bug before that happened. That happens to me all the time. So we see that a lot in our code, and oftentimes we'll see things that we wished we had unit tested when our QA engineers find those bugs.
We need to get you to speak to my team. Because we don't always have unit tests in the PRs. Is there a way to add a timeout to these asynchronous tests?
Yes. So the timeout task that I demonstrated for you, you could wrap the asynchronous test with the timeout task, and then that would time it out as soon as either the success is reached, which would be the end of the test, or the timer reaches the end of the time. So those two tasks run in parallel. The one that's passed to the completion is the one that is achieved first.
Nice. We've only got a couple left, actually, so we might get through. So what additional handling can you do to prevent a waiting test from hanging forever? I feel like that might have been covered with the previous one, but maybe, is there anything else to add on that?
Well, I'm sure there's a lot of area to explore here. I've been working with this and playing with this for the past few months, and there's lots of times where I have not been able to find a solution for solving a hanging test other than fixing the original function that I'm testing. So it could be that there's some things that just aren't available to us yet and that will be developed soon and will be added to the code base soon. It could be that there's some strategies that I haven't identified yet and the other people who are researching and experimenting in this area haven't quite found yet.
Cool. This was a really good question, actually, that just came in. What is the code coverage of your project?
So we have an engineer on our team who is pushing for 95% code coverage. Yeah, so he's amazing, and he's one of my great mentors. However, We're not quite there yet.
Yes, we're definitely not there yet. Excellent. Yeah, there's a couple more, but I think we'll get to those maybe on Slack. So yeah, you've travelled from Philadelphia?
Philadelphia, that's right.
Philadelphia, so a long, long way to come in and speak to us all. So yeah, big round of applause for Allison.